Okay, I'm going to demonstrate the harmonic series using my violin, which is convenient because you can not only see the different patterns of vibration, but hear them as well. The different patterns of vibration that you can get on a string with fixed ends are shown here, the first 8 patterns. The first one being the fundamental pattern, or first harmonic, then the second harmonic, third harmonic, etc. Each pattern has, each successive pattern has an increasing number of lobes, meaning regions where it's vibrating. So this one has 1 lobe, L-O-B-E. This one has 2. This one has 3, coinciding exactly with the harmonic number. And the actual pattern that you can see it on the string. I'm going to play a G here, and hopefully what you'll be able to see is that the string is fixed here at the bridge and fixed here at the what's called the nut, but it's vibrating in a pattern that looks like this. So it has an antinode here, meaning it's vibrating at its maximum amplitude here, and it has nodes, N-O-D-E, here and here. To create the second harmonic, I can touch my finger lightly on the string halfway between the bridge and the nut. Now I'm not going to push the string all the way to the fingerboard, but instead just lightly touch my finger to the string in order to cause it to vibrate in 2 pieces. So I don't know if we can see that on camera. Should be able to see that there's an antinode here where it's vibrating at maximum, and here, and a node here where my little finger is. So that's the second harmonic. And I'd like for at least the musicians in the audience to notice the difference in pitches between the first harmonic and the second harmonic. That's an octave. It's 8 notes on a piano keyboard. Bum, bum. And if you know how to sing Somewhere Over the Rainbow, then you know what an octave is. Somewhere over the rainbow. So the first 2 notes are in an octave relationship. Then the third harmonic I can create on the violin by splitting this distance between the nut and the bridge into 3 equal pieces. So now I'm causing it to vibrate in 3 segments. It's a little harder to see, I think, on the camera, but and the musical relationship between these 2 is a musical fifth. And if you know Twinkle, Twinkle, Little Star, the first 2 notes of Twinkle, Twinkle, Little Star are a fifth apart. So that gives that third mode, the musical fifth. Then if you go up to where you're dividing it into 4 equal pieces, then you've quadrupled the original frequency. Each time we go up from one mode to the next, we're increasing the frequency by the same amount, by 100 hertz, by another 100 hertz, by another 100 hertz, etc., etc. And that's another octave. Here's the fundamental again. Bum, 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 are all octaves apart. The next harmonic is the major third, which you can get by dividing the string into 5 equal lobes or portions. So there's the 4th harmonic, and there's the 5th harmonic, and those are a major third apart. Then back another 5th. Bum, 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 and the last 3 notes that we did are the 3 notes that form the major triad in Western music. Bum, 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 a note, a major third above it, and then a 5th above that. Then the final one here that I want to mention before the octave is the minor 7th, Sorry, it sounds a little squeaky, but it's about bum bum. And that's the minor seventh, a little flatter than some musicians might recognize it normally being, and we'll talk a little bit more about that later. And then finally, the last one we'll talk about is the octave. I'm not sure I'll be able to get it on the violin. But these continue indefinitely to an effectively infinite number of modes of harmonics that appear in the harmonic series. And it's the presence or absence of the various harmonics in the sound that gives each instrument its characteristic tonal quality. So the oboe is heavy on the third, fourth, and fifth harmonics for many of its notes. The flute is heavy on the fundamental and octave and fifth, first, second, and third harmonics. The violin has different characteristics, and that's one way you tell instruments apart. So to demonstrate how this works, some instruments are only able to play harmonics in the harmonic series. The trumpet or the bugle is one of them. The bugle is a trumpet that has no valves. And what the trumpet player does with his lips, his or her lips, is to adjust the frequency in order to create these different harmonics. And you can't play all the notes that way, but you can play some of them. So I'm going to do the same thing that the bugle player does, but on my violin, using only harmonics, not putting my finger straight down hard on the string to get different notes, but just utilizing the harmonic series. So that's Reveille. And I guess to finish off, maybe I'll demonstrate a little bit about what you can do with a violin. You can do it not only physics demonstrations, but you can play it. This one's called the Orange Blossom Special. It is about a train that used to run from Miami, Florida, where the orange blossoms grow, and New York City. And so it's supposed to sound like a train. The violin's supposed to sound like a train. It's supposed to sound like a train whistle.